to get the result to do analysis, we use Python to do the analysis. First, let me just recap the whole data science process. First, we gather the business requirement, what are the business requirement, what are the our targets for doing analysis. Then we have to acquire data from wherever we want, from a data set or through APIs or through multiple areas. Then we clean data, then process data or clean data using SQL, Excel, and Python also. Then we rearrange the data properly, so it will be can be used in a better way, or it can be so the analysis can be performed in a better way. Now, after doing the analysis, we do the analysis, we get some results like accuracy, precision, MSE, mean absolute square value, mean square value, everything. So, what are these value? What is the use for? And how will you get it? We're going to discuss it in this lecture. So let's start today's lecture. So why do we evaluate models? So here are the few points are there to explain this. Number one is to explain how well the model predicts the outcome. To test the to test our model that if it is doing the correct prediction or not, or to get the outcome of the data set we want, the outcome we want, the research we want from our data set. The second point is to compare predicted values with the actual values, by doing this present and using ML models, you're going to predict some future value also. So if you continue purchasing this product, and you will ask the model, if I keep purchasing this, what will the outcome? What will the outcome of the after 3 months, or after 6 months, after 1 year? And it will give you some answer. Then after and you follow that, and after 1 year you get you get the exact result which your ML model was able to predict. You're gonna compare it and you're gonna see the, oh, this is the correct thing. So my ML model is predicting right. The next point is to detect the errors and improve performance. What are the wrong things you are doing? What is the things you are doing which is harmful for the business or harmful for managing anything, what you are managing, or what kind of work you are doing, to detect errors. Now the next point is to ensure the model works well on the real world data. And the last point is model evaluation is essential before deployment. You're going to test your model, before deploying it, that if it is doing things correctly or not, if it is doing predicting things correctly or not. Because after deployment it is very tough to redo the whole thing. It will take lots of time also, lot of cost also, so time complexity will be high. So it is not a good move. So first we have to analyze and check whether our model is predicting things correctly or not. Then we're going to move further with it. So I think it is clear to you all. So let's move on to the next slide, which is what is accuracy? Accuracy. So accuracy is measured percentage of correct prediction, like how many the total number of predictions are there, and through which what are the correct predictions. Like for example, if 90 out of 100 predictions are correct, then the accuracy will be 90%. Suppose I ask ML model that predict how many times I'm going to uh, suppose how many times I'm going to uh, do well in these exams. If I given data that I've studied this much, and do this much study, this much of PVQ, this much of self study time, this much of this much of revision. So after doing this, after continuing this, how much time I will give good marks. So if then the ML will analyze it and predict, or after in the 10 upcoming exams, you are going to perform well in 90 exams, and so the accuracy will be 90%. Similarly, if the performance is 95%, 95 out of 100, then the accuracy will be 95%. Okay, accuracy alone can be misleading with the imbalanced data set. Now, if your data set is not correct, if your data set is based up messed up, like missing values, duplicacy, or anything else. It is messed up data. It's not a correct data. It is a half data. No, you're having a half information, or you're having a misinformation. Then the accuracy will be really bad. The accuracy will be not good for you to analyze it. Even if you analyze correctly, you everything do correctly, and the data set is not good. It is imbalanced. It is not correct. Then the accuracy will also be, and the accuracy can be also not be good or not accurate. So accuracy has some limitations also. So what are the limitations? Let's check. Like 95 normal transaction, 5 fraud cases. Suppose a fraud detection, let's take example of fraud detection algorithm, which 95% was a normal transaction and 5 was a fraud cases. Model predicts it's a normal because 95% you have 95% accuracy. If you have 95% accuracy, it's a good thing. But actually 95% accuracy, but detects zero frauds. Have 95% accuracy, but it detects zero frauds. Conclusion: never rely on the accuracy when the class's distribution is uneven. Never ever rely on just accuracy to when your class is uneven, or in general also you don't rely on the accuracy alone, because accuracy only give you a certain perspective. You have to add some more thing also, like precision and the recall value, which I will going to explain in the next slides. That is why are also very important. So overall everything, if everything scores good, that means your model is working well. If something is not good or something is not predicting well, if the accuracy is high but the precision or recall value is less, that means there's some fault in your system. Please do a correct it, whether it is in data set or whether it is in your ML model or your analysis part. Okay. So let's talk about precision. So accuracy is the one thing. Accuracy is the total rate of success out of total. So the rate of success out of total number of attempts. Suppose you attempted 10 times and you have success in 6 times. So your accuracy will be 60%. Is that, I think accuracy is clear? First of all, let me ask: is accuracy is clear to all? Do you want me to explain it again? If you want, just tell me. I will explain it again only. I don't have any problem. Okay, I can see some stuff. So let's move on to the precision part. Yeah, this is. So what is precision? Precision can be measured how many predicted positive were actually positive. What it means, out of 100 times, your model predicted that the out of 100, suppose that 100 true false questions was there, suppose, and out of 100 true false question, you asked your ML model to predict the correct answer, means positive answers. The correct answer is positive answer. Keep this in mind. So it has predicted, though it has predicted that your 70 model is your positive model or the correct answer. Out of 100, 70 is your correct answer. Okay, which is your accuracy also. Okay, and what precision tell that out of that 70, how many of them what was actually correct or actually true, partially positive. Like out of 70, you've the model predicted out of 70 is correct, and you've checked once again and you got that out of 70 only 60 were correct. So 10 were not correct, but your ML model predicted is correctly. So that means it is a positive, but it is false also. So correct is positive, 70 is correct, and 70 means 70 is positive and 30 is wrong. This 30 is negative. Also 70 positives, the true positive means the actual correct is only 60. So 60 is true positive, and your the rest 10 was positive, but they were wrong. That means they were false positive. They was not actually correct. they were predicted correct, but they were actually wrong. It means they were false positive. So do you understand the false positive and the true positive thing? If it is predicted correct and it is actually got correct, it means it is true positive. It is if it is predicted correct but it is actually found wrong, it is false positive. Okay, and so the in the total number of positive thing you have. So there's a formula also to calculate this. Here you can see in the screen also, TP slash divided by TP plus FP. So TP means true positive, FP means false positive. So true positive divided by true positive plus false positive, but the total number of positive which were predicted by the RMN model. So the when you calculate that, you will get the precision. Okay, now understand. Now let's read the other points also. Focus on the prediction quality. The accuracy is the your prediction, and the quality of the prediction. If the predicted value is correct or not, it is called the quality of the prediction, which is of precision. So when to use? It is majorly used in spam detection and recommendation system. Why? Because in the spam detection, many of the spam messages are there, but one or two are the real message, or the message you want, or the message related to your work is there also. So identify a difference between the spam message or a normal message. You're gonna use this precision and a recommendation system also. These two are the most example the precision is used. Now, high precision means favor false alarm. The high precision means favor of false alarm. Okay. Now we have the recalls also. After covering the whole set, I will give you the revision of the whole set also. Then the whole thing properly. I can see there's a question. This is the handed. Okay, sure. If 70 was corrected, then the accuracy was 70. But checking the precision, it was the 60 outcome. Then how can they say the accuracy was correct in 70? So that's thing, na. Accuracy is not the total answer or not the correct answer. The precision is to be the exact correct value. Accuracy will tell you uh, uh, the total number of correct predicted value, and the precision will tell you after the those accuracy what is the actual correct value. Is it clear? So is it clear, Shubham? um, is it clear now? Can you say yes or no anything in the chat box, please? Okay, let's see thumbs up. Shubham, but tell me, is it clear to you? Okay, okay, I can see thumbs up. Okay, 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 okay. Just wait a few seconds also. I will come back to it after completing the whole slide, and then I will explain you once again also. So now we have the recall value. Okay, recall measures how many actual positive were correctly identified. What does it mean? That just a second. A recall measures how many actual positive were correctly identified. What is mean that uh, see, as you can see, let's focus on the formula first. It is total positive divided by total positive plus false negative plus false positive. So as you can see, the when a model is predicted, the 70 out of 100, that 70 is correct and 30 is wrong. You saw that in the precision that out of 70, only actual correction was only for 60 only, but 10 is false positive. But if the model can predict some wrong thing, some negative thing positively in the accuracy part, it can also predict on some positive or some some correct things in that negative world also. So there can be some positive thing or correct answer in our rest 30 questions also. So that question which were actually correct, that part which are actually correct, but predicted wrong uh, by our ML model was called false negative. And now let me just understand you true negative, true positive, false positive, false negative. So the whole thing is there. Positive means correct, negative means wrong. Okay. True positive means which is predicted correct and got correct. Okay. False negative, which is predicted correct, but actually it was wrong. Okay. Then we have false positive and false negative. Sorry, true negative and true false negative. True negative was the thing which was found negative, which was predicted negative, and actually it was negative. That is true negative. And some part which were predicted it is negative, but it is actually positive. That is false negative. Is that clear? False negative, false positive, true negative, true positive thing. You can just thumbs up if this is clear to you all. Okay. So let's read out some points. Recall measure how many actual positive were correctly identified. Focuses on capturing all real cases. Critical in disease detection and fraud detection also. High recall means we were missed cases. High recall means if your recall value is high, it means you have predicted many there are many there are many false negative also, which is predicted negative, but actually it is positive. The it means your prediction is not right. Okay, so in precision, you got that it is said high precision means we were false alarm, means high precision means that the two it means that it can just reduce the false alarm. If the precision is high, it means that true positive thing is out of the whole positive area, the true positive is the majority, means it is the model is predicting all things correctly, or the majority of things correctly. It means uh, it just reduce the false alarm, or reduce anything wrong. And in recall, you can see it waiver the missed cases, or it actually finds the actual positive cases which were in the negative. So the format also is very clear. True positive divided by uh, true positive plus false negative plus false positive. All the positive value, including the false predicted also. Okay. Now, now we have the next slide, which is precision versus recall. So some of you also are getting a lot of confusion between recall and precision. I will just clarify you. What is more important? It depends on the business problem. What kind of problem you have? Like fraud detection, recall value is priority. For spam related problem, precision is important. For medical problem, the recall is important. Why recall is important? But because it measures how many optional positive were correctly identified, which means if someone's if and let's take an example of a disease detection also. If suppose ML model was there and it had to identify whether the person has suppose let's take a disease cancer or not. So if the all the reports go through the ML model, repeated that no, the person don't have or have so suppose let's see it had 70% chances of having 70% chances of having the cancer, but in the accuracy is there. But in the recall, you can check that no, there are some more chances because there was some points which are missed by the RML to and so the it because 70% chances is there and 30% chances it don't have any thing related to cancer, but in 30% there are some few points which is missed. If you count that point, you will get no, there are more chances. So in 30% there are more the more percentage shift from 30% to the 70% part. No, so it then after doing the correction we can tell that oh the our chances of getting cancer is 90% or 80%. That means if the person has cancer. Okay. Okay. Now we have the F1 score also. What is F1 score? F1 score is balance, precision, and recall. Now, useful when data set are imbalanced. They are useful when data sets are imbalanced. That's why see accuracy, as you can see in the accuracy point, it is written that yeah, it is in that the accuracy can alone be misleading with the imbalanced data set. With the imbalanced data set, you can't trust only accuracy. Accuracy can be false also. But you can see in the F1 score helps to helps when that data set are imbalanced. So in accuracy, with the part the accuracy can't do, the F1 score will do it for us. Okay, helps in to determine the overall classification of strength. Recruiters often prefer F1 because it will balance performance. As you can see, that here is the formula is also there. Like 2 into precision into recall. Okay, this is a formula for F1 score. It has a combination of both recall and precision combined. Okay, then see here you can see here is the two positive. Here is the false negative thing. Here is a predicted positive is there, and this is the true positive thing. It's the middle. This is the false one which is predicted correctly, but actually it was false. Yeah, it is the it's true negative, which was predicted negatively. It was actually negative. Okay, these are the odd formulas you can learn also. But so there is not very you can just see this formula also. You don't have to just memorize this formula. You have to get some ideas of this what these measures do, because in data science you don't have to write any exams to or what is precision, what is accuracy. You have to just know about what is these and why these are important. Accuracy can't be so important, but accuracy can be misleading in some imbalanced data set where F1 score is important. And to you to have F1 score, you need to have your precision and your recall also. So overall, these are four things: your accuracy, your F1 score, your recall value, precision. All four are important. And why these are important? I think you got it the point. Why these are important? To check your data to whether they are the check a model where it is predicting correct or not. It will be checked before deploying the model. Now we have regression model metrics. What are these? So there are three types: mean absolute error, mean square error, and root mean square error, RMSE. So there's a different these three things. I will explain one by one. Used when so they are used when predicting numerical values. They are used when you have to predict a numerical value. See, every accuracy, F1 score are different things. These are different things. When you need to predict an numerical value, you need to have these. What is the main goal? Main goal of this to measure the size of the predicting errors. how many errors you are predicting, what is the size of the error you are predicting, is it very big or less, you're going to predict with using this model. Okay, see all the things which are studied just now, FNS score accuracy and recall and precision. These are the things which related to not errors. These are the how many correct things you have got, how many correct things you have got, how many correct things were there in the which is repeated not correctly. You know, and this is the all about the errors. How many errors you got? What is the size of the error? You know, like that. Now we have mean absolute error. What is mean absolute error? Calculate the average absolute difference between predicted and the actual value. Mean absolute error means that the real difference between the predicted value and the real value. The difference between them is called error. That this much prediction was not correct, or this much prediction was wrong. That is the error. That is the mean absolute error. Okay. It is easy to interrupt. Example. Let's take a simple example. Mean absolute error. 5 mean prediction are of about 5 units, preferred for business reporting. Sorry for that. And they are generally preferred for business reporting. Okay. Now we have mean square error and root mean square error, MSE and RMSE. Square errors are penalize large mistakes. Useful when big errors are unacceptable. Okay. Yeah, a mean absolute error has more two types, which is mean square errors and mean square errors and root mean square errors. So and root mean square errors, the square root of MSE. You're gonna calculate MSE, and if you're gonna take the square root of it, you're gonna get your RMSE. See, these are not you're gonna not have to write these things by your own, or calculate this by your own. Your computer will do this for you. Your algorithm will going to do this for you. You just will know what is these values are and why these are important for your business. Okay, these are absolute mean square value, mean square error, root mean square error. These three things are the is like your errors. How many errors you got out of the full prediction? What are the errors? How many wrong things you got? Be all about errors. Okay, useful when big errors are unacceptable. Mean square error. Mean square error penalize when large mistakes. These are used in large mistake in the square value, and the mean absolute error when the error is not very big. You're going to use this. Okay, and the root mean square error is basically the square root of the MSE. Okay, expressed in the same unit as the targeted variable. Most widely used regression metrics. RMSE is one of the most widely used regression in to calculating the errors. Out of these three, RMSE is the most widely used. But why it is widely used? Because it gives a good answer. It gives a more correct answer, or more accurate error. If you want to calculate the error properly, it will give the most accurate. Now, what is R2 score? Indicates how well the model explains the data variability, which means score that, which means, yes, take example of this, like 0 poor model, 0 to 5 moderate, 0 to 7 strong, 9 or 9, 0.9 plus excellent. This is the rating out of 1. 1 is like your 100, and this is the 0 is the zero point 0.5 means I think 50, and this is means I think 70, and this is excellent is suppose 90. So indicates the how well the model explains the data variability. The data variable, how well is data variable, where it is it a poor, moderate, strong, or excellent. Higher R square means the better model is fit. The more high R square value is there, means your model is good. The low R square value is there, it means your model is wrong. And you don't have to get the R square value to you to know the answer. After calculating your accuracy, precision, F1 score, recall, these after calculating these things only, you're gonna, if the answer is correctly, you're gonna get, if you got your answer correctly, you're gonna get, oh, my the model is correct or not, the model is predicting things correctly or not. Now we have the common beginner mistakes. Using accuracy for imbalanced data set, which I have personally done this mistake also. Ignoring recall in higher expedition. Choosing metrics without a business context. You have to choose your metrics, which is important according to your business metrics only. You don't need all things in all your related I mean, you all related your uh, uh, you don't need all your accuracy prediction F1 score in all your predicting value. It depends on your the requirement of the business, what kind of things you get. Like the project we're gonna do as a mini project in this one, the student performance analysis. We don't use this much of things, these are the we don't use this much of things. We're gonna need graphs and the pie chart to analyze students performance. Okay, avoiding the mistakes to improve the model reliability. Don't avoid your mistakes your model gives. If your accuracy is not good, if your precision is showing errors or anything is there, uh, go and improve your model. Check your dataset first. First of all, check your dataset. Then please check your model also, if it is correct or not. If you don't find any mistake, first of all, you check your dataset. But because the most of the time, the mistake was in your dataset only. First of all, check your dataset. If you don't find any mistake over there, then you go to the model and check your model if it is correct or not. Now, in the conclusion, to evaluate model efficiently, understand the problem type, which was the problem, choose the right metrics, compare the prediction carefully, optimize continuously. You have to optimize your model continuously according to the market, according to the new models coming up. Remember, the best metric depends on the business goal. What kind of requirement you business have, you first you gather that information, then you want to get what is a good metrics to evaluate your analysis will be there. Now, thank you. This is the lecture, and now tell me, do you found any difficulty in this lecture, or what do you want me to explain again? Is there any problem? Please ask me carefully. Ask me, please. This is really important to me. Today this was also very short because nothing much to explain. If I added the graph part, it will take I think more than 1 hour. I will do in some other lecture or some other lecture only. So if you have any problem, please ask me.